Welcome to our quick guide on data representation, tailored for the new Igcse computer science syllabus. In this video, we'll explore how computers store, process, and transmit data in various forms. From the music on your smartphone to the photos on your computer, all data is represented digitally, allowing electronic circuits to handle it efficiently. We'll cover the different types of data, including numbers, letters, sounds, and images, and see how computers use numeric codes to represent everything. Let's dive into the fascinating world of data representation and see why it's so essential in modern technology. Number system is a method used to represent numbers in computer architecture. It's the foundation for how computers process and store all types of information. There are four main types of number systems you'll encounter: binary, octal, decimal, and hexadecimal. Each system has its own base and set of symbols. Understanding these systems is crucial because computers rely on them to perform calculations and manage data. In the next scenes, we'll break down each system, starting with binary, and see how they're used in real-world computing. Let's briefly introduce the four main number systems. The binary number system with base 2 uses only 0 and 1. The octal system has base 8 using digits 0 to 7. The decimal system, which we use every day, is base 10 and uses digits 0 to 9. Finally, the hexadecimal system is base 16, using digits 0 to 9 and letters A to F. Each system serves a unique purpose in computing, from simple calculations to complex data processing. We'll start by exploring the binary system in detail. Binary number system is the language of computers. It uses only two symbols, 0 and 1. Each digit in a binary number is called a bit. Computers use binary because it matches the on and off states of electronic circuits, making processing faster and more efficient. If computers use decimal, they'd need to handle 10 different states, which would be much more complex. That's why almost all modern devices, from smartphones to laptops, use binary internally. Let's see how binary numbers are structured and why they're so important. Decimal system, or denary, operates in base 10 using digits 0 through 9. In contrast, the binary system uses base 2 with only 0 and 1. The base of a number system is also called the radix. Understanding the difference between these systems is key to converting numbers and performing calculations in computer science. The table shown here compares the two systems side by side, making it easier to see how numbers are represented differently in each. Uncommon task in computer science is converting decimal numbers to binary. One method involves dividing the decimal number by 2 repeatedly and recording the remainders. These remainders, read from bottom to top, give you the binary equivalent. For example, converting 107 to binary involves several steps of division, as shown in the diagram. This process helps you understand how computers break down numbers into binary for processing. Let's try another example, converting 114 to binary using an 8-bit register. The process is similar. Divide by 2, keep track of the remainders, and fill in the bits from right to left. Using an 8-bit register means your answer will always have 8 digits, even if some are zeros. Practicing these conversions helps you become comfortable with binary numbers, which is essential for understanding how computers store and process data. Now let's look at converting binary numbers back to decimal. Each bit in a binary number represents a power of 2, starting from the rightmost bit. By multiplying each bit by its corresponding power of 2 and adding the results, you get the decimal value. This method is fundamental for understanding how computers interpret binary data as numbers we use every day. Binary arithmetic is similar to decimal arithmetic, but it uses only 0 and 1. You can perform addition, subtraction, multiplication, and division with binary numbers. The rules for binary addition are straightforward. 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is 0 with a carry of 1, and so on. Mastering these operations is crucial for understanding how computers perform calculations at the most basic level. Ones and twos complement methods are used to represent negative numbers in binary. The ones complement is found by flipping all the bits, changing zeros to ones and ones to zeros. The twos complement is found by adding 1 to the ones complement. These techniques are essential for binary subtraction and for representing signed numbers in computers. Bit shifting is a process where binary digits are moved left or right. Shifting left multiplies the number by 2, while shifting right divides it by 2. This operation is commonly used in computer programming and digital electronics for efficient calculations. The diagrams here show how bits move and how the value changes with each shift. Let's look at some practical examples of bit shifting. By moving bits to the left or right, you can quickly change the value of a binary number. These examples help you visualize how shifting works and why it's so useful in programming and hardware design. Here's another example to reinforce your understanding of bit shifting. Practice makes perfect, and working through these examples will help you master the concept. Notice how each shift changes the binary value and what that means for calculations. Hexadecimal system is base 16, using digits 09 and letters AF. It's widely used in computing because it's more compact than binary and easier for humans to read. For example, the binary number 11111111 is simply FF in hexadecimal. Hexadecimal is often used to represent memory addresses, color codes, and more. Converting hexadecimal numbers to binary is straightforward. Each hex digit corresponds to a group of 4 binary digits. For example, the hex digit A is 1010 in binary. This direct mapping makes it easy to switch between the two systems, which is especially useful in programming and digital electronics. You can also convert binary numbers to hexadecimal by grouping bits in sets of 4 and matching them to their hex equivalents. Similarly, hexadecimal numbers can be converted to decimal by multiplying each digit by its place value and adding the results. These conversions are essential for understanding how data is represented and manipulated in computers. To convert a decimal denary number to hexadecimal, divide the number by 16 repeatedly and keep track of the remainders. These remainders, read in reverse order, give you the hexadecimal value. This process is similar to decimal to binary conversion and is a key skill for computer science students. Hexadecimal numbers are used in many areas of computing. They're common in programming, especially for memory addresses and color codes in web design. Hex is also used in debugging and low-level system work because it's more compact and readable than binary. Understanding hex is essential for anyone working with computers at a technical level. Computers can't process sound in its natural analog form. Instead, sound is captured often by a microphone and converted into a digital signal using an analog-to-digital converter. The converter samples the sound wave at regular intervals, recording each sample as a binary number. This process allows computers to store and manipulate audio data efficiently. Sample rate is the frequency at which sound samples are taken, measured in Hz Hz. For example, CD quality audio is sampled at 44,100 Hz, meaning 44,100 samples per second. Higher sample rates capture more detail but require more storage space. Understanding sample rate is important for working with digital audio and ensuring high-quality sound. Computers have limited processing power and storage space. To make the most of these resources, we often need to compress files, reducing their size for faster transfer and more efficient storage. Compression is especially important for large files like images, audio, and video, which can otherwise take a long time to download or upload. Compression reduces the amount of bandwidth and storage space required for files. It also shortens transmission times, making web pages, songs, and videos load faster. Any type of data can be compressed, and the impact is significant, especially when dealing with large amounts of information. There are two main types of compression: lossy and lossless. Lossy compression removes some data to reduce file size, which can result in a small loss of quality. Lossless compression, on the other hand, preserves all the original data, allowing the file to be perfectly reconstructed. Each method has its own advantages and is used for different types of files. Lossy compression reduces file size by removing some of the original data. For images, this might mean reducing the number of colors. For audio, it could mean reducing the number of samples. JPEG is a popular lossy format for images, while MP3 is common for audio. The trade-off is a smaller file size at the cost of some quality. Lossless compression keeps all the original data so the file can be restored exactly as it was. This is done by finding patterns in the data and encoding them more efficiently. Zip files are a common example of lossless compression. While the space savings aren't as great as with lossy compression, there's no loss in quality. To summarize, compression is vital for efficient data storage and transmission. Lossy compression is best for images and audio where some quality loss is acceptable, while lossless compression is used when every bit of data must be preserved. Choosing the right method depends on your needs and the type of data you're working with. Binary digit is called a bit, and 8 bits make a byte, the smallest unit of memory in a computer. Some computers use larger bytes like 16 or 32 bits, but they're always multiples of 8. Since a single byte doesn't store much, memory size is usually measured in larger units like kilobytes, megabytes, and gigabytes. A nibble is a group of 4 bits or half a byte. It's also known as a tetrade. Nibbles are useful for representing small amounts of data, such as a single hexadecimal digit which fits perfectly into 4 bits. Understanding nibbles helps you see how data is organized at the lowest level. Calculating file size is an important skill. The size depends on the number of bits or bytes used to store the data. For example, a text file size is determined by the number of characters and the encoding used. Images, audio, and video files have their own formulas based on resolution, color depth, and sample rate. We've covered the basics of data representation, including number systems, binary arithmetic, hexadecimal, sound representation, compression, and memory measurement. These concepts are the foundation of computer science and are essential for understanding how computers work. With this knowledge, you're well prepared for your IGCSE exams and for deeper study in computing. Every digital device you use relies on binary data. Smartphones, tablets, computers, and even smart home devices use binary to store and process information. Understanding binary helps you appreciate the technology you use every day and gives you a foundation for future learning. Programmers often use hexadecimal because it's more compact and readable than binary. Memory addresses, color codes in HTML and CSS, and error codes are often written in hex. Learning to read and write hexadecimal is a valuable skill for anyone interested in coding or it. Media files like images, music, and videos are often compressed to save space and speed up downloads. JPEG and MP3 are common formats that use lossy compression, while PNG and FLAC use lossless compression. Knowing the difference helps you choose the right format for your needs. When you buy a computer or smartphone, you'll see memory sizes listed in gigabytes or terabytes. These units are based on bytes, with each step up representing a much larger amount of data. Understanding these units helps you make informed choices about technology purchases and usage. Digital music relies on sound sampling. The higher the sample rate, the better the quality, but also the larger the file. Musicians and audio engineers must balance quality and file size when recording and sharing music. This is a direct application of the concepts you've learned about sound representation. At the heart of every computer is the CPU, which performs millions of binary arithmetic operations every second. Addition, subtraction, multiplication, and division are all done in binary. Understanding these operations helps you see how computers execute programs and solve problems. IGCSE exams often ask about number system conversions, binary arithmetic, and data compression. Practice these topics to build confidence and improve your test scores. Understanding the underlying concepts will help you tackle any question, even if it's worded differently. To succeed in data representation, practice converting between number systems, work through binary arithmetic problems, and understand the differences between compression methods. Use diagrams and tables to help visualize concepts, and don't hesitate to revisit challenging topics until you're comfortable. There are many resources available for learning more about data representation. Subscribe at Igcse Level Online YouTube channel to deepen your knowledge and prepare for exams. Regular review and practice are key to mastering data representation. Set aside time each week to work on exercises and revisit topics you find challenging. Over time, you'll build a strong foundation that will serve you well in computer science and beyond. Data representation connects to many other areas in computer science, such as algorithms, programming, and hardware design. Understanding these connections helps you see the bigger picture and apply your knowledge in new ways. Stay curious and keep exploring. The world of computer science is vast, and data representation is just the beginning. As you continue your studies, you'll discover new topics and technologies that build on what you've learned here. Thank you for joining us on this journey through data representation. We hope this summary has helped clarify the key concepts and prepared you for your IGCSE exams. Keep practicing, stay motivated, and remember, understanding data is the first step to mastering computer science.